Well, hello everyone. This is Dr. R. Jefferson George, and this is um, Education Leadership, EDLE 6110, Week 6, and this is our video for Linear Regression, Introduction to Regression. And after looking at all of the material that we have today, this might be a short video, but we're going to look specifically at if you want to use your textbooks, you can follow along. We're going to look at, if you go to page 55 in the textbook, we're basically looking at a simple linear regression, which is a little bit more than a correlation, because in a correlation, as you know, we are looking at the relationship between those variables. And but when we start looking at a prediction, at a regression, a simple regression, we're trying to predict something, trying to use those numbers, those variables, for one to predict something of the other. And so in your text, he had a very good example, and I thought we would just use that. Table 5.1, and it shows the relationship between GPA, the grade point average of 10 students, and the hours that they spent studying at home per week. And so, so let me show you what I did. You can, like I said, you can follow along in the book, and I'll show you what I did in the book. But so I have opened up my SPSS, and so I already had it open here. So minimize that. Here we are. So let's start with the this page in SPSS. Let's start with the variable view page. And since I have already created this, let me just show you. We're going to type in the names of the variables. And it's much easier to type in the names of the variables in advance. So type in GPA, and then once you type it in, I'll type it in underneath here just so you can see how that works. Then we'll delete it. But if I type in GPA, and then if I just move it to the next, oh, we can't duplicate that. If I type in GPA2 and move to the next variable, you see it populates the whole row for us. And so it takes care of all the things that we need. And then you can go over here and click scale. So, and you'll do that for both of them. And I'm going to go ahead and delete this variable because we don't need it. And press clear. So now we have our two variables. And so if we go to the data view, and then see that way it gives you the names of the variables here and here. So here are our two columns, our 10 students. And so I just typed in the values. So student 1 had a GPA of 3.5 and spent 6 hours studying per week. Student 2, 2.8, and 5 hours studying per week. And student 3, 3.6, and 6 hours studying per week. So I'm already seeing a trend here. So once you get your data in, very easy, go through there, get your data in, and then if you're following along in the book, the next thing that the book asks us to do, and then we always need to do, is to look at a scatter plot. So the easiest thing for us to do to find a scatter plot is to go up here to graphs and go down to regression variable plots. And as you can see, they're going to give you two variables that we've entered, our variables that we've entered. And we want, this case, hours studied to be on the vertical axis, and we want GPA to be on the horizontal axis. So in other words, GPA at the bottom, and hours studied going up the y-axis, and GPA on the x-axis. So if you click on options, there really isn't anything we want to change on that. Make sure that linear is selected, and you can add a chart title if you want. And press continue, and then look at this and press OK, and it'll take us to our output and provides us with a scatter plot, and it draws a regression line of best fit. It draws that for us. So very nice for SPSS to take care of those things. But as you can see, here are the hours studied, 3 hours, 4 hours, 5 hours, 6 hours. And it gives us the GPAs 2.6 through 4.0. And if we were to extend this line this way, we would find where it intersects the y-axis at 0. And as I was saying in the content area, well, this is slope. And so if you remember your 9th grade algebra, you were creating slope. And that was a big deal in 9th grade algebra. So if you want to go back down to your SPSS icons at the bottom, then we can go back to our data page, shows us our data. And then the next thing we want to do is very simply, we did see a relationship in there, but you know what, we didn't do a correlation. And so let's do a very quick correlation between these two bivariates. And so I'm just going to put both variables over there, and we'll make sure it says Pearson, make sure it says two-tailed, flag significant correlations. We'll look at options. No, we don't need means and standard deviations, so we can continue. And we're not doing anything else, so you don't need to change anything else in the commands. And so in this case, press OK. And so we come down here, and importantly, look at the correlation. So here's your correlations between our two variables, GPA and hours studied, GPA and hours studied. And it tells you that they have a correlation, and it's statistically significant of 0.657. And if you look in your book, it tells you that if you square that to look for the effect size, you'll come up with 43. Or 0.43 times 100 would be 43%. So it's telling you that the correlation is explaining 43% of the variance between the two variables. So very good. So it sounds like we're on a roll here. And so the next thing we want to do is, well, go ahead and then let's run the regression in SPSS. So go to Analyze, go down to Regression, and we're going to do a linear regression. This is a simple linear regression because we're only having one, we're only really looking at two variables. We're not looking at, it's not a multiple regression because we're not looking at more than one. But we have one dependent variable, which is GPA, and we want to see the effect, the impact of hours studied on GPA. And to make sure, right here, we can certainly do estimates. We can do confidence intervals at a 95% confidence interval, model fit, descriptives, and that should be enough. We also we don't need to run another graph, so we'll just cancel that. And there we go. So we have our all we have to do is have our two variables here, our dependent variable GPA and our independent variable, which is hours studied. Press OK. And interestingly enough, it gives us our descriptives if we wanted to know the mean and the standard deviation of GPA and hours studied. It gives us our correlation again, which is very good. It gives us our variables entered, so it's telling us what we did. It gives us our model summary. And fascinatingly enough, they are exactly the same models summaries that we have in our textbook. And so if you'll look, and then just to create a realization here, the R, the regression R, 0.657, is the same correlation coefficient that you get when you do the Pearson correlation, 0.657. Just wanted to point that out. If you square that, you get 0.432, and times 100 is 43%. So we know that our model is accurate and that it's explaining, it's a very good model, very good fit, and it's explaining 43% of the variance between the relationship between the two variables. And so then the next table that it shows us here is the analysis of variance, or the ANOVA table. And so we're not going to talk about the whole table. In the very back of your textbook, you'll see that there is a table of F values. I think it's on page 182. It's an F distribution table. And we'll maybe talk a little bit about that in week 7. But we're really looking at, here's the value. An F value of 6.072 is kind of high. And so that's good. And if we look over at the thing that says sig, or significance, that's telling us that the regression is statistically significant at 0.039, which is less than 0.05. So probability is P of is less than 0.05, which tells us that there's less than 5% chance that the F value this large would occur by chance alone. So it's just telling us that it's statistically significant at the 0.05 level. And so, it's a good fit. And so, and the next thing that we're looking at gives us, no, we're not going to, and then you can look here at the coefficients, and the coefficients, it's giving us a little bit more, I think, than what we asked for, but if you look at B, or beta, if you're looking at, it gives you a B of 1.9. And when we are explaining our variables, which is kind of fun, so here's our constant. It's saying that if you have a GPA of 1.9, or if you don't study at all, then we're going to start there. This is where the slope cuts the y-axis, basically crosses the y-axis. So in this case, it's saying that if a student does not study at all at home, and so they can expect a GPA of 1.9. And so what the rest of it is telling us is that if we look down there, hours studied, the increments or the units, or 0.28. 0.28 then would be the equivalent of raising your GPA by 0.28 for every hour studied. So you could create on your slope, you could create a scale that would every 0.28 on your scale would raise your GPA, so by 1 unit. And so if you continue to raise your GPA, then you could theoretically get to a 4.0 by continuing to study more and more hours per week. So I think that, but it gives a good model fit, and it tells us that there is a strong relationship between your GPA and the hours studied per week, and that you're able to quantify it by putting it on a slope through a regression line. And you found your model of best fit, and and you're able to predict GPAs based on the hours of study per week. Now you could do this with any of the things that we've been looking at. We've been looking at benchmark testing and MAP scores, and so you could look at MAP scores, and you could run a regression, a linear regression between MAP scores and the STAR scores a student might score in that particular subject, and you'll be able to create a predictability. So if a student scores this, if a student has this score on a benchmark, then it would be very predictable to say that they would score this on the STAR score, on the STAR test. And so you would be able to create that sort of a relationship in there. So very good. And then so here's your scatter plot. Very same scatter plot that we saw earlier, although when we ran it earlier with just looking at the two variables, we came up with our line of best fit that goes right through here that shows our slope. So there's lots of things to play with as you go through this regression, but I think that for what we're doing right now in this simple linear regression, this is what we need to concentrate on. Your assignment this week, if you wanted to take a look on page 62, your assignment this week would be a continuation of this activity. And I want you to take the application activity on page 62, enter those scores, run all of these analyses, and then you can copy and paste it over into Word and submit it as a Word document. So I think that would be an acceptable way to end this, and I look forward to seeing everyone, all of your work in the linear regression, and thank you very much.